Chapter 7 is one of our lengthier chapters, so our topics list is a little bit bigger, just to remind you anything with a star is a no calculator problem. So in Chapter 7 we covered law of sines, law of cosines, and then area, and I'm only going to focus on the side angle side formula, so you don't have to worry about Huron's formula. And remember, those all had to do with triangles. Then our next section of Chapter 7 was plotting complex numbers and converting them to polar form. Converting to rectangular form, so that's taking polar form and converting it to rectangular form, and then we're only going to focus on the product of polar form. So remember, that was like our second section of Chapter 7, and then finally we're going to finish out with De Moivre's theorem for roots and then vectors as well. So starting off with law of sines and law of cosines. So the first four, it was a mix of both law of sines and law of cosines. So whenever we're given a triangle and it asks us to find all the missing angles and sides, we're going to first start by drawing a picture of it. So it says angle A is 40 degrees. So I'm going to label this A, B, and C. So angle A is 40 degrees. Side A, so remember I look at angle A and I go directly across. This would be 54 inches. And then side B, so across from angle B is 62 inches. So first I have to decide what kind of triangle is it. So I see I have an angle here, a side, and then a side. So it has to be an angle side problem, or side side angle. And remember, these are the special ones that could have one triangle, two triangles, or zero triangles. So once I realize that it's a side side angle triangle, I'm going to do a little copy and paste to make sure I get both triangles complete. So first thing I have to do is solve for the angle across from the given side. So I already have angle A and side A. So I'm going to solve for angle B using law of sines. So it's going to be 62 over sine B equals 54 over sine 40. Now to solve for B, I'm going to cross multiply first. So it's going to become 54 sine B equals 62 sine 40. And then I divide both sides by 54. So I'm left with sine B equals 62 sine 40 over 54. So I get to this part and then I have to recall, how do I separate sine and B? So in order to separate sine and B, remember we take something called the inverse. So in your calculator, make sure you hit second sine, so you get that sine -1. And then you're going to plug in this fraction. So when I plug it into my calculator and round to the nearest degree, I get a degree of 48. So my B value in my first triangle is 48. Now this is where I split up into my second triangle. So I take this B value and I do 180 minus 48. When I do 180 minus 48, here I would put that new number. So I would get 132. Now to decide if this is an actual triangle or not, what I do is I look at the angles already given to me. So angle B, which I just wrote in, and then 40. So if I look at 132 plus 40, I would get 172. Now 172 is less than 180, and a triangle adds up to 180, so therefore this is a triangle. If when you add those two numbers, it's greater than 180, then it cannot be a triangle. So since this is less than 180, it is a triangle. Therefore, I have to solve both of these triangles. So I'm going to go back up to the first one, and then I'm going to do the second one. So to solve for angle C now, triangle adds up to 180. I just take the other two angles and subtract them from 180. So angle C would be 92 degrees. Then to figure out side C now, I would have to set up a proportion using law of sine. So I'm still going to use my given information, which was side A, so 54 over sine 40. And then I'm going to solve for side C now, so I have to use angle C. And again, to solve for this, I'm going to cross multiply. So I'm left with C sine 40 equals 54 sine 92. I'm going to divide both sides by sine 40. And then I'm going to plug that into my calculator. So when I plug that into my calculator, I get a value of rounded 84.0 inches. So remember, you're rounding to the nearest tenth. Therefore, even if when it's 83 point something and we round it to 84, you still have to have that value in for that tenth. So therefore, here it is 0. So in my first triangle, these are my 3 answers. And now I'm going to move on to my second triangle. So in my second triangle, I have to solve for angle C. In order to do that, I take the other 2 angles and subtract them from 180. So angle C is 8 degrees. And then what I have to do is I have to solve for side C now. So I'm going to still use angle A and side A. So this is going to be 54 over sine 40. And then this time I'm solving for angle or side C, so I have to use the angle C of 8. So again, I'm going to cross multiply. And then to get C alone, I divide both sides by sine 40. And then I plug that into my calculator. And when I round it to the nearest tenth, I would get 11.7 inches. So those are my 6 values because I used side-side angle, which gave me 2 different triangles. So that's law of sines. Like I said, it's a mixed review of law of sines and law of cosines. So I'm going to let you try the next 4 or next 3. To find the area of a triangle with side, angle, side given, you have this area formula on your reference sheet. So all you're going to do is you're going to plug in your values given to you. So we're solving for K. Now, it doesn't really matter what the sides are. Just know the lowercase in the formula means sides, and then capital letters mean the angle. So the angle is A here. So I'm going to plug in 63 next to sine. And then for my sides, B and C, it doesn't matter where I plug those in as long as it goes in for A and B in my formula. So this is going to be 24. This is going to be 11. And then sine 63. And you can plug that all into your calculator at once. Since this doesn't say to round, I'm going to leave it as it is. So it's 117.6128 feet squared. And that is my value for K. Try the next 2 and then move on. So the next one is plotting each complex number and then converting it to polar form. So as a side note, since this is started on calculator, a lot of polar or complex numbers have that value of radical 3. So just know that radical 3 is about 1.7. So first we're going to plot this number and then convert it to polar form. So to plot -3 plus 3i, I'm going to start at the origin. I'm going to move over to the left 3 and then up 3. So that is my z. Now to convert it to polar form, I need 2 things. I need the absolute value of z and I need to know theta. So first, absolute value of z. This is a formula you had to memorize. So it's square root of a squared plus b squared. What we do is we plug in our a, which was -3. We plug in our b, which was just 3. And then we simplify. So in case you don't know where I got those numbers from, remember this is a and this is b. So -3 squared is 9. 3 squared is 9. 9 plus 9 is radical 18. To simplify that, I could break this out to radical 9 and radical 2. So I would get 3 radical 2. Make sure you do leave it an exact value. I do not want a decimal here. Then we have to find our theta. So this is another formula you should have memorized. So tan theta equals b over a. So this would be tan theta equals 3 over negative 3, which means tan theta equals negative 1. So if you think about where tan is 1, that's 45 degrees. However, we're looking for a reference angle, or this is our reference angle, so we have to find our real angle. So if I'm looking, my point is in quadrant 2, which means I do 180 minus my reference angle, and then that would be 135 degrees. So, therefore, in polar form, z equals 3 radical 2 cosine 135 degrees plus I sine 135 degrees. And this is another formula you had to memorize, so remember it was z equals r times cosine theta plus I sine theta. Now, I just want to go back to this reference angle. How did I know tan of theta or 45 is 1? Remember on 5.1 there's that chart you had to memorize. So at 30 degrees, tangent is radical 3 over 3. At 45 degrees, tangent is 1. And at 60 degrees, tangent is radical 3. So I knew that tangent, when it's negative 1, it had to have a reference angle of 45, because that negative just tells me what quadrant it is in. And if you think about all students take calculus, tan is negative in quadrants 2 and 4, so it makes sense that my point's in quadrant 2 and tan is negative. So if you don't have those memorized yet, I would definitely recommend it. The next 3 you can complete on your own, and I'm going to go on to how to convert to rectangular form. So again, this is starred, which means that it's a non-calculator question. So what we do is we focus what's on the what's inside the parentheses first. So we're going to think about our unit circle. So you really need to memorize your unit circle. For this, we're looking where cosine is 60 and what the exact value is. So cosine 60, the exact value would be 1/2. So remember, cosine is x on your unit circle. And then for sine 60, that's your y value. So at 60 degrees, sine is radical 3 over 2. So now what you do is you distribute that 4 to each part. So it'd be 4 times 1/2 plus 4 times I radical 3 over 2. And then you're going to simplify. So 4 times 1/2 would give me 2. And then these I could simplify, so this would be 2. So this would be 2I radical 3. Or you could write it, which I want you to write it like this, 2 radical 3I. So this would be my final answer. So there's 3 more problems just like that. So try those. The next one is just product. So we did product and quotient. However, I'm just going to ask you product if it's on the exam. So I'm going to give you 2 equations, and then you have to memorize that formula in purple there. So what we do is we take both r's, we multiply them, and add our thetas. So this would be 4 times 8, and then cosine 50 plus 100 plus I sine 50 plus 100. So to simplify this then, I would get 32 times cosine 150 degrees plus I sine 150 degrees. And that would just be my answer. So product is pretty straightforward. You multiply your R values and add your thetas. So there's 3 more just like that. So try those. And then you can move on to the next part, which is finding all the roots. So if I ask you to find the roots, this time it says write in polar form. Remember, when we find roots, we have to start in polar form. So this says find the cube roots of I. Now I is not in polar form. Remember, z equals a plus bi, that's rectangular form. So technically this is z equals 0 plus 1i. So what I have to do is first convert this to polar form. So again, I need my absolute value of z, and then I need my theta. So absolute value of z would just be 0 squared plus 1 squared. Well, 0 squared is 0, 1 squared is 1, square root of 1 is just 1. So my z value is 1. For tangent, it's b over a, so that would be 1 over 0. So we're thinking about where tangent is undefined, and if you think about your unit circle, it is either at 90 degrees or 270. So if I plot this point 0, 1, it's up here. Therefore, tangent is 90 degrees. So to write this in polar form, it would be 1 cosine 90 plus I sine 90. And now what I do is I use that formula on my reference sheet, which is c to the power of, or subscript k, equals n square root of r times cosine theta plus 360 times k over n plus I sine theta plus 360 k over n. So that is on your reference sheet, remember? And now, to figure out n, you're looking at how many roots. So cube means 3 roots. So to figure out k, you always start at 0 and then go however many numbers that n is. So n is 3, so I only need 3 numbers. So k is 0, 1, and 2. So I'm going to do k 3 times here. So starting with k being 0, this would be cube root of 1 cosine 90 plus 360 times 0 over 3 plus I sine 90 plus 360 times 0 over 3. So to simplify this then, z0 would be 1 times cosine 30 degrees plus I sine 30 degrees. So that's z0. Then I would do the same thing with z1. So it'd be cube root of 1 cosine 90 plus 360 times 1 divided by 3 plus I sine 90 plus 360 times 1 divided by 3. So when I simplify this one, I get 1 times cosine 150 degrees plus I sine 150 degrees. So far I have 2 answers, and then I need to do z2. So z2 now is cube root of 1 cosine 90 plus 360 times 2 divided by 3 plus I sine 90 plus 360 divided by 2, or times 2 divided by 3. So when you simplify that, z2 would be 1 cosine 270 degrees plus I sine 270 degrees. And therefore, that is my third answer. So you have 3 more to try of that kind, and then we're going to move on to vectors. So for each vector, it wants me to find the magnitude and the direction angle. So magnitude's the same as absolute value, where it's the square root of a squared plus b squared. Direction angle is the same as tan a equals b, or tan theta equals b over a. So first I'm going to plot this vector. So -4, I go to the left, up 4, radical 3 is up, So my vector looks like that. To find absolute value now, or magnitude, this is this formula. So for A, I would do negative 4 squared plus 4 radical 3 squared. To simplify that, negative 4 squared is 16. To simplify this, 4 squared is 16, and then radical 3 squared is just 3. So 16 times 3 would give me 48. Then I'm going to add those two together. I would get 64, and then the square root of 64 is just 8. So my magnitude is 8. So that's one of my answers, and now I have to do direction. So direction angle is tan theta equals b over a. So I'm using my b and the a they give me, and that would be 4 radical 3 over 4, or over negative 4. So tan theta, if I simplify, is negative radical 3. So again, it's only negative because it's in quadrant 2. So we have to think of a reference angle in quadrant 1 where tan is radical 3. So on the 2 previous pages I told you how to, or you had to memorize that chart where at 30 degrees tan is radical 3 over 3, at 45 degrees tan is 1, and at 60 degrees tan is radical 3. So if you had that memorized, this is a lot easier. So here I see tan theta equals radical 3. So I know that has to be somewhere at 60 degrees. Since this is in quadrant 2, to find the actual angle, we use the reference angle formula. So 180 minus 60, which means my direction angle is 120 degrees. So you really got to know what that tan values are, especially because this is not a calculator question. The last thing we did in this unit was dot product. So these are my equations, and then I'm going to do the dot product. So I'm just going to replace u and w with their vectors. So it would be 4, 6, 4, dot product 5, 1, negative 2. So first we have to do scalar multiplication. So I'm going to distribute this 4 to both parts, and then this 5 to both parts. So this would be 24, 16, dot product 5, negative 10. So for dot product, remember I multiply these two numbers and then add them to the multiplication of these two numbers. So it's going to be 24 times 5 plus 16 times negative 10. So 24 times 5 is 120. 16 times negative 10 is negative 160. So my final answer is 40. So remember, dot product is the only kind of operation with vectors that you end up with a single number, not a vector. So that is all of chapter 7. Make sure you try it. The answer key is online for you.